Hi all. Welcome to the cloud, I suppose, evening and learn. Obviously not lunchtime. So my name is Joseph Keown. I'm going to be the moderator today. Just in relation to the topic conversation today. The title is No, I Don't Need Servers for .NET Development in AWS. And our presenter today is Rob Van Pammel. Rob, if you could introduce yourself, that'd be great.
Yeah, okay. Hello everyone. So my name is Van Pammel and I'm a .NET for Access, which is a Belgian company actually. I'm a developer since 2007 and I started working with WinForms applications and then got sooner attracted towards web development and now already working more and more in the clouds. And yeah, that's about it for me.
Perfect. Thanks, Rob. Yeah. So I just an FYI and a heads up. Rob will be going through his presentation now, and then we won't take questions until the end. So it should roughly take around between 50 and 55 minutes for Rob to go through his presentation, and then at the end we'd have like a 5 to 10 minute call. It doesn't matter if we kind of go over the hour. Rob, I'll let you take it away there, and I'll just go in the background. Thanks.
Yeah. Okay. Thank you. Like I mentioned, my name is Rob, and I started working with cloud computing in around 2015 or something like that. And I got into AWS when I was working with a Greenfield project around that time. At that moment, we had the opportunity to take a look at different cloud providers like AWS, but also to Azure or Google Cloud. And then actually, we selected AWS, which was not an obvious decision if you're already working with .NET. But anyhow, after a few moments or after a few years, we also saw that AWS is heavily investing on .NET. They are also a sponsor of the .NET Foundation. So that's why we also are still glad that we made that decision. But we're not talking about AWS or something else. We're talking about serverless computing today. I think most of us already know what serverless computing is. It's about running code without the hassle of service, making sure that you don't have to provision your servers, that you don't have to do the patches and all this kind of stuff. But I'd like to take a step back and take a look why serverless became a buzzword that it is at this moment. So what's a better way to do this than taking a look at Google Trends? If you look at Google Trends for serverless, you see that it starts to hype around 2015, 2016. But when I dig then more into details about AWS Lambda, I saw that this became actually a little bit sooner, around 2014, 2015. And I started to ask myself, now, how is this? Because AWS Lambda is serverless, so it should be equal. Well, actually, when AWS Lambda was introduced at reInvent 2014 by Werner Vogels, the CTO of AWS, it was not introduced as a serverless computing service. No, it was introduced as an event-driven computing service for dynamic applications. Yes, he was already mentioning that you don't have to provision any servers anymore, and that you don't have to do the patches, etc., etc. But what got my interest over there is that he was talking about event-driven architecture as well. And when I started to do some more research, I saw that around the same time in 2015, 2014, that some other great people were working on the Reactive Manifesto. For example, Dave Farley, who has written the book of continuous delivery, was also working on this. Now, this Reactive Manifesto, what is this? Well, the Reactive Manifesto is all about creating reactive applications. What are now reactive applications? Well, reactive applications are applications who remain responsive at all times. Where application is responsive, at that moment, it will raise the quality of your application and it will boost your user confidence. But now, what is actually a responsive application? If we developers are thinking about responsive applications, we immediately start to think about making sure that you have a low latency in your applications, that you have fast response, etc. But it's not only that. It's also a matter of if you're having a problem in your application, that you can handle it very effectively and very fast as well. So it remains responsive at all times. How can you create such applications? Well, you can create them by making sure that they are resilient. Now, what is resiliency in an application? Resiliency in an application means that whenever there are problems that are happening in your application, that you can isolate those problems and that they don't pop up to the user interface, for example. Now, how can you do this? You can do it by making sure that these parts of your application are, for example, that they are duplicated. So if you have two instances running of a given service, if one service is going to have a problem, that the other instance of your application can still take over. You can do this by duplicating your complete application, but you can also making sure that you're going to divide your application into smaller parts, which have their own responsibility. If they're having their own responsibility, if a part of the application is failing, it's only a small portion of the application which is failing, and then the other parts of the application are still working, so you remain more resilient at that moment as well. Another technique that you have to do if you want to make your applications responsive is that you have to make your applications elastic. And when we hear elastic, we already start to think about scaling your application up or down, which is correct. If you're having a higher load in your application, then you need to shovel in more resources to your application. But also, if the load on your application drops, you must be able to take resources away from it so you don't have to pay for everything as well. On top of that, if you're making elastic applications, it's not only adding or removing more resources, but it's all about making sure that there are no bottlenecks anymore in your application. We will see in a moment that a lot of applications having a bottleneck is most of the time a SQL Server, for example. But we will see that later on in the presentation. Now, if you want to make the applications more responsive, you can do this by making sure that they are message-driven. Message-driven means that you're going to make use of asynchronous communication between the different parts of your applications. So we make sure that the application parts are loosely coupled and that we can control the flow of the messages which are going to move around in your application. If you're doing all of this, at that moment, you will make sure that you have a more maintainable application, which is on top of that even more extensible. And that is what we all want, making sure that we don't have to spend all day long maintaining the applications and we don't have time anymore for adding more features. No, we want to add more features instead of maintaining it. And if it's more extensible, it's more easy to add more features as well over there. Now, in 2014, why were they doing this? Well, at that moment, a lot of applications were still making use of synchronous communication. And all the applications that I have written at that moment as well, we were still making use of that synchronous communication with a request-response style. For example, if we had a web shop application which had a checkout service, but also an invoice service, it was a request-response style. For example, let's say, create the invoice, and that happened. Doesn't seem too bad, actually, but there is already something wrong over here. If we're going to add more services, it will become more clear that, for example, the checkout service has more dependencies. At this moment, it's coupled towards the invoice service, but it's also coupled to the shipping service and also to the contact service. So if it's the checkout service's responsibility to call all of these applications. But it's not only the checkout service who has the responsibility. No, it's also the team who is maintaining the checkout service, which gains more and more responsibility. For example, if the shipping service over here has a breaking change, well, it's up to the checkout service team who needs to implement that breaking change. So, that is not a very good situation we have at that moment. On top of that, we see that if you're having more and more services, latency will increase as well. So what we have over here, well, yeah, more services will be added over time. We have more responsibility for the different teams and latency is increasing. And what we see actually in real life is that we are not very keen to ourselves as well. For example, over here, instead of just adding another service, we will squeeze in even another service, we'll add one more. And let us take a look what goes wrong if the stock service in this example goes out of stock. Now, who is responsible for making sure that if something has been checked out and there is no stock anymore, that no invoice is going to be sent? Is it the stock service who should do it? Or should the stock service call the checkout service, who then has to call the invoice service to make sure that there is no invoice being sent? Or should the stock service send something to the contact service? Or I mean, you can already see that something is going wrong over here, and the responsibilities, who has to do what, is not very clear. That is because all these services are tightly coupled together. Now, how can we resolve this? We can make sure that we are going to build our application in a message or event-driven architecture way. Well, let me first introduce the events. Well, an event is something or a change in state which has happened in the past. What is important over here is it happened in the past. So it did already take place, so you cannot change it anymore, which is important. On top of that, if we're going to create that message or event-driven architecture, we will make use of asynchronous communication. You will see, for example, over here that the checkout service is now connected towards a service bus, which is going to decouple our services from each other. Now, if the checkout service is going to send something to the other services, well, the checkout service only has to call the service bus, but it's actually up to the other services to subscribe to the event that the checkout service is going to send out. At that moment, the service bus will broadcast the messages and trigger an endpoint in that service. And if we're doing it this way, we are actually reversing the flow. At this moment, it's not the checkout service anymore who is responsible for making sure that all the other services receive the message. No, it's the shipping service and the invoice service who is responsible for making sure that they receive the message by subscribing to that message as well. Now let us take a closer look how we can, or how these techniques have been already applied to a serverless architecture. First, let us take a look at the first part over here, which we see. We see over here some architecture which has a user interface, for example, a web application or a mobile form. This web application or mobile form is going to connect to an API gateway. It will rely on AWS Cognito for identification and authorization. And afterwards, it will call a Lambda function who can fetch some data from a DynamoDB, etc. It's a straightforward architecture, which we will explain more in depth. Now, Lambda function is the serverless function of AWS, and we will discuss this first. I already mentioned in the beginning that AWS Lambda was introduced in 2014, and they didn't have to provision the infrastructure anymore. But what's important over here is that, yeah, it's going to be executed by a given trigger. So it's really already event-driven, the thing that we already want if we want to build the reactive applications. Some other advantages that it gives is that if we're making use of AWS Lambda, which is event-driven, is that it will be scalable. For each application or for each request which will be executed, a new Lambda function will be created and will be executed. If we have parallel executions, more and more instances of that same Lambda function will be created, so it can happen in parallel as well. On top of that, we have some more advantages. It will reduce our costs, for example. If we have an application which is not running all the time, we don't have to provision and we don't have to pay for a service which is running 24/7. No, we're only going to pay for the amount of time that the AWS Lambda was running. It will make our life for developers a little bit easier as well if you want to write code. Why? Well, the function will be a lot smaller. You're not going to create a big monolith inside an AWS Lambda because it will not run. You will create smaller parts which have only one responsibility, so you can make it easier for yourself as well. And just because you're not going to create a container or a virtual machine, you will just deploy your code that you have written it will end up with the fastest deployment as well. But there are some drawbacks as well. I mentioned over here that the latency that we have, our response latency, can increase if you're making use of AWS Lambda. This is just because we can have some cold boots, which will I explain later on as well. But this is one of the drawbacks that we have with AWS Lambda. Another part as well is that for debugging and monitoring, it isn't as easy as it was before. Just because you have more and more pieces which are scattered around your application landscape that you will have to monitor, it will not make it easy to see what's going on. But there are solutions for that as well. Now let us take a closer look in such a Lambda handler, or how does it look like. If you take a look at how it's in C#, for example, you will see over here that function handler, and that for each method that you see over there, well, this is the part where all your business logic will be executed. What else do you have over there? Well, you have an event. In this case, it's an SQS event, which is coming from a queue. And this will be something specific for each type of integration that you have. You have integrations for SQS, you have integrations for an API gateway, or for a DynamoDB stream. All the information or all the parts of the event which have been executed will be available in that first parameter over there. The next one that we have is the Lambda context. Now, what is the Lambda context? The Lambda context contains all the information on how your Lambda function is running. For example, there is a timeout for 15 minutes for each Lambda function. How much time remaining will be present inside your Lambda context. But also, for example, if you have assigned 128 megabytes to your 128 megabytes of RAM to your Lambda function, you can already see how much memory it has been taken, how much memory is still free, which kind of version is available, etc., etc. All this is then available in that Lambda context. What is important over here is that that function handler, which we see over here, is going to be executed on each request that will be executed. Now, there are three ways that a Lambda function can be executed, or can be, we have three different invocation models. We have a synchronous invocation model, which has the request response style that we just discussed about. This is, for example, for an API gateway or for a load balancer, it will call a Lambda function in a synchronous way. Important over here for making sure that the applications still remain resilient is that you know that the error handling which is occurring at that moment is the responsibility of the client. So, for example, if an error occurs in your Lambda function, which is triggered by an API gateway, at that moment it's up to the API gateway to make sure that it's going to translate it to an error to your end user. For example, over here, what will happen in case of an API gateway? Well, an HTTP status 500 will be returned to your end user. The second invocation model that we have is for async communications. For example, S3, which is the blob storage which we have on AWS, or SNS notification service. These are going to be really event-based invocations that we have, really asynchronous as well. For error handling, making sure that you are resilient, what will the Lambda function do? Well, the first time it will retry it up to 2 times. And afterwards, it will, depending on how you have configured it, it will add the message towards a dead letter queue where you can continue working on it. Or it can be moved to a Lambda destination, and at that moment, some other Lambda function can pick it up and move away. What else do we have? Well, for queues and for DynamoDB streams, we can poll these kind of services. What will happen at that moment? Well, the Lambda function will accumulate all the events or all the changes which have happened, and will pass those towards your events inside your Lambda function. So at that moment, it can get processed over there. So if you have 5 messages on a queue, you can pass 5 messages to one Lambda function, And at that moment, your Lambda function will process those 5 messages of your queue. Important over here to mention is that if something goes wrong in your Lambda function while processing these messages, it's up to the Lambda function as well to make sure that either if something goes wrong, that event is going to be skipped, or in case of an SQS queue, you can configure that letter queue over there as well. What will happen if you don't do it? Well, at that moment, it's possible that your Lambda function keeps retrying that message as long as the data is valid. For example, on an SQS queue, it can be up to 4 days that your Lambda function will keep retrying to process the message, just because, yeah, it's not going to remove it or it doesn't know how to move it away from the queue. Okay. Now, I mentioned in the beginning as well that, yeah, AWS Lambda can increase your latency. That's something that we don't want. And mentioned as well that it comes due to the cold starts or concurrency that we have. So let us take a closer look what happens actually if we're going to start a Lambda function. There are 4 different parts which are going to be part of it. The first step that will be done is downloading your code. Next step is starting up a new execution environment and executing some initialization code for your Lambda function as well. And then the next step, or the last step, your handler, which we just saw, is going to be executed. Now, these 4 different steps is what we call a cold start. What we actually want is a warm start. Now, the biggest part is actually downloading your code and starting the new execution environment. And this is the part where we don't have any control on. AWS will start a new execution environment and will throw it away as well after your Lambda function hasn't received any requests in a few minutes. The more memory you assign to your Lambda function, the longer it will be present. But at a given moment in time, it will be thrown away by AWS Lambda, and then, yeah, it will have to start over again to downloading your code, starting your execution environment, etc., etc. Now, what has the community already done for this? Well, they started to create some kind of Lambda warmers. So to make sure that your Lambda function keeps receiving requests, at that moment, AWS Lambda will not throw away your environment as well. So you get a warm start every time, you might think. But that's not really the case, because AWS Lambda is a service which is running on a region, which means that it is running on different availability zones as well. So it's perfectly possible that your first request in your region will be processed in a Lambda in availability zone 1, but the next one will be in another availability zone, which might still lead to a cold start. So that's a solution, but it's not a solution which is good for the 100%. What else do we have? Well, if we have parallel executions, well, at that moment, we will still face a cold start, just because there's only one Lambda function which is running, and yeah, we are not able to squeeze in another one. So we will still face a cold start. Now, what can be done, or how can we resolve it? Well, AWS has then launched what they call provision concurrency. Now, provision concurrency is actually a way that you will pay for a given amount of instances that you have of your AWS Lambda that they will keep warm. For example, over here, there are a provision concurrency of 6, which means that 6 instances of your AWS Lambda will remain warm. So whenever a request will kick in your AWS Lambda function, there will be a Lambda function ready as long as there are no more than 6 concurrent requests, for example. Also, on multiple availability zones, this will be the case. Now, I mentioned that if you're looking at our AWS Lambda function, we only want to execute that function handler once. We know now how a cold start work, we can take a little bit advantage of this as well. For example, if in your business logic you have to initialize some heavy objects or etc., etc., if you move those initialization code towards your constructor over there, at that moment you can gain some time as well, because that constructor will only be executed once and it's not part anymore of your function handler. But be careful if you're having some kind of initialization and it's possible that due to the execution of your business logic that initialization got corrupt. At that moment, as long as your Lambda function will be warm, at that moment you can have a corrupt handler which will lead to more and more errors. Now, we don't have any control how or when that execution environment will be thrown away, and you don't want to pay too much as well. So I mentioned that if you're going to assign more memory to your Lambda function, it will be longer available, which is true. It will also affect your CPU and your network. So the more memory you assign to it, the faster your CPU will be and the faster your network will be. But of course, you will have to pay more as well. And if you want to tune this to make sure that you get the best out of performance, but also the lowest bill from AWS, at that moment you can take a look at some tuning applications or some tuning repositories as well. For example, over here there is a repository which will guide you and give you then some kind of a graphic where you can then find the sweet spot between performance and execution time. Okay, that was actually the first part, the most heavy part, I think. Next part is about making sure that we still don't add more and more bottlenecks to our application, which is the DynamoDB or the database part. Now, why am I telling this? Well, because I see that data storage for serverless applications or for event-driven or reactive applications might be a little bit different compared to the traditional style of storing our data. Relational databases, or the traditional way of storing data, started around 1970 and is still working till today. What we saw at that moment in 1970 is that they took a look, or they designed their databases with the characteristics of that time as well. And we saw in the 1970s that what was very expensive was the storage, actually. So what have guys like Edward Codd done, which is the kind of the inventor of relational database? He started to normalize the data that we're going to store in our database. Now, what is normalization? Normalization is actually making sure that you're going to compress your data so it doesn't add or doesn't take too much storage, so you end up with a cheaper solution in the end to store your database. What we also see at that moment is that relational databases at this moment are mostly running as a single server. You can add some read replicas to it, you can apply some sharding as well, but in the end, they are actually much harder to scale compared to a CPU or a web application. But they are still useful. They're still useful for analytic processing, but for online transactional, they are not that useful anymore, in my opinion. Because what we saw with the rise of the cloud from 2000 to 2010 is that we had more and higher demands to our applications. Our applications were running 24/7, so they need to be more reliable. More and more people were making use of our applications, so they need to have better performance and they need to scale better as well. What we also saw at in 2000 to 2010 is that our CPU performance was flattening. Till then, we had the Moore's law, which was dictating that every 2 years, the amount of transistors that we had on the CPU was doubling. Well, in 2000 to 2010, this started to turn a little bit as well. And on the other side, we saw that the storage got cheaper and cheaper as well. There were big cloud vendors which were making sure that you can have 1 gigabyte of data for only $1. And now it's got even cheaper and cheaper. And that's when people started to reinvent how data could be stored on an application or for an application. For AWS, they invented DynamoDB at that moment. Now, what is DynamoDB? DynamoDB is the NoSQL database that AWS offers you. It's mainly built for online transactional processing, so not for any analytics. You will see in a moment why this shouldn't be done with it. And what DynamoDB is offering you is a single millidigit second response time to all their API queries. Now, how can they guarantee this for you? Well, this is because they have built DynamoDB in a way really for scaling. What you will have to do if you're going to configure your DynamoDB table is you will have to configure how much read and write capacity units that you expect to have, which means how much time or how much time do you expect to be read or written from or written to your database. You will have to configure that, and at that moment they can deliver it. But to make sure that they can deliver it for you, they have another mindset in storing the data on your database. Now, what we see in DynamoDB storage is that all the data that is going to be stored in different partitions. Now, how does such a database look like? Well, imagine that you have multiple tables over here. On each table, you have different items. Well, those items are going to be stored in different partitions. An item will be stored in one partition, while the next item can be stored in a completely different partition, and so on. Which means that actually, if you know that each partition is going to be served by another server, is that you can scale horizontally over all the different partitions, which you can, or which you might compare a little bit with the sharding that you have on relational databases. Of course, there are some limitations on it. You have a maximum throughput on a partition, and you have a maximum item collection as well that you have on on the partition. Sorry. Now, I've mentioned that data will be stored differently. Well, if you're going to look at how it's going to be stored, you will see that it will need to be fetched differently as well. If you look at such an Amazon DynamoDB table, it consists out of a primary key. The primary key can be a partition key and an optional sort key. And then you have all kinds of different attributes. The primary key is the only way to fetch your data, which means that you have to know upfront how you will fetch your data from the database. So you have to know your access patterns. If you have a view that you're going to show on your website, you will have to know which things you will have to show over there, so you can fetch the data based on the primary key at that moment. Now, how can you choose your primary key? Well, you can make use of, for example, a session ID or an order ID to store the data. Just make sure that you have a high cardinality attribute added towards the primary key, so you end up in a lot of multiple partitions, which will give you then better and better performance. It's also possible that you're going to compose different attributes together inside an attribute key. I will see it in a few minutes as well, how you can do that. Now, which API actions do we have for fetching data out of a DynamoDB table? Well, there are three. You can do it based on, or you can fetch it based on a given item. If you look at the table over here, you have a table with some actors, some movies, and some different attributes. If we want to fetch the movie of Tom Hanks in Castaway, we will specify the partition key, Tom Hanks. We will specify the sort key, Castaway, and then we will fetch all the relevant attributes over there as well. We can make use of a query. A query can be done on a table or on different indexes. And you can say, for example, with a query, I want to fetch everything with a partition key of Tom Hanks. I'm going to leave the sort key out, for example, and then those items will be returned, Castaway and Toy Story. But you can also say, for example, I want to fetch the query from Tom Hanks and a sort key which starts with a T, for example, and then the one from Toy Story will be returned. Important to know over here is that you will always have to specify your partition key. Except for scans. What are scans? Well, scans is actually that if you have all the different partitions, it will literally scan all the different partitions that you have. And if your data matches on your partition, it will return it over there. Just because he has to scan everything, it's a very expensive operations. So not only on your AWS bill, it will be expensive, but also when you want to create a responsive application, it might take a while before he has scanned all these different partitions. But at that moment, you can return everything you want. Now, I mentioned in the beginning that you have to know your partition key to fetch your data, which is correct, but that's only one way to fetch your data. If you want to enable more access patterns, you can create secondary indexes. What is secondary index? Well, a secondary index is just another way to specify a partition key and a sort key so you can fetch the data from your database. There are two different flavors of it. You have a local secondary index, which has the same partition key, but can make use of another sort key. Or you have a global secondary index, which can use a new partition or a new sort key. For example, over here, at this moment, we can fetch the data from our actors. For example, Tom Hanks. We can fetch all the movies that we have. But there is no way that we can fetch, for example, who has played in Toy Story. If we want to do that, at that moment, we have to switch the partition key and the sort key, which can be done in a global secondary index. At that moment, we can fetch it from here, Toy Story, which is now the partition key as a movie, and then we can fetch all the relevant actors which have played inside of it. Now, what we see is that a lot of developers, if they start to work with DynamoDB, is that they are missing one concept, which is the concept of joins. Joins don't exist in Amazon DynamoDB. The reason for that is that joins are actually very expensive, which might look very scary if you don't have any joins, but they have a solution for it, which is called a single table design. Now, what is actually a single table design? Well, it means that you have to store all your entities of that relevant service in one table. We are already working with a NoSQL database, so you only have to specify your partition key and your sort key, and the attributes are free to choose, so you can store everything inside of it. Now let me come back why joins are expensive. Well, if you want to join two different tables with each other, you will have to fetch all the data over in the one table and all the data in the other table, and you will have to correlate this. And this is taking a lot of CPU power for it, which makes it expensive. Now, actually, why do we need to do this? Well, we need to do this because we normalized our data. We split it already out. So if we don't split it, if we don't normalize our data, then at that moment you don't need any joins anymore. So if you make use of a single table design, it can give us some performance advantages. It will give us less operational overhead just because you don't have to worry anymore about making sure that you have backups of 3-4 different tables. It's only one table that you will have to take care of. And for read and write capacity units, well, you only have one table, so it can be cheaper over there as well. Of course, it's not a holy grail. There are some disadvantages as well. It's a little bit inflexible if you want to add new access patterns, but it's certainly not impossible. And it's not as easy as it looks in the beginning. So it has a steep learning curve if you want to start with it. Now, one concept of single table design is what they call partition key overloading. Now, I already mentioned that we're going to store the multiple items in one table. But if we're going to store multiple items in one table, now how can you see that, for example, over here that we have an organization or we have a user? You don't have any difference anymore because you have just a partition key and you have a sort key. Well, at that moment, we can start prefixing our data with the kind of entity that it is. For example, we have an organization. We're going to prefix it with org. Or if we have a user, we will prefix it with the users over here. If we're going to make use of this concept, we will be able to even enable more and more access patterns as well. But I agree with most of us that it doesn't look very intuitive at the first time. So let's take a look at some data design strategies that we have. Let us say that we have a one-to-many relationship where a customer has multiple addresses. For example, we have a customer over here, and we have some home and business addresses as well. Now, how could we store this inside a DynamoDB table? Well, one way to do this is to make sure that, or to make use of a complex attribute over there. If we denormalize our data into it, for example, over here we see the mailing address, we have the home address, but we also have the business address inside of it. It's perfectly fine to store it over there. When can you do this? Well, if you don't have any access patterns for the data, if you don't have to search for it, for example, on the business address, at that moment you can make use of it. Also make sure that you're not going to store too much data inside of that attribute, because there are some limits over there as well. So if the amount of data is unbound at that moment, you can't do this. Another example is we have an author which has written some books, and we want to show all the information of the author on the website together with his book. Now, how can we do this? For example, if we want to show also the birth date together with the books, well, at this moment, we're going to make use of duplicating our data. The author, his birth date, that will not change anymore. So that data is immutable. So we can make sure, we are free to duplicate it over there as well. Data is cheap at this moment, so there is no problem in that. But take a look as well to how often does the data change. In this example, well, it's not going to change anymore, the birth date. But if it still changes, well, if it's only 1 to 2 times a year, for example, that it changes and it doesn't change a lot of data anymore, well, at that moment, I think it's still a valid possibility to use this pattern. What else do we have for an example? Another with an organization and some users. For example, over here, we have the organization with its metadata of Microsoft, and we have the users of Microsoft, Bill Gates and Satya Nadella. Now, you can see over here that I have already made use of that single table design by prefixing it with an org and with the user. Now, if you want to retrieve the information from the organization, so this one and the metadata, at that moment we can specify the partition key organization #Microsoft and sort key metadata #Microsoft. At that moment, all the relevant data will be our end users. If we want to retrieve the organization, but also the users, at that moment we can make use of a query API, which is going to specify the partition key, but we will remove or we will not specify the sort key. At that moment, the metadata, user, and the different users will be returned as well. If we want to retrieve only the users, at that moment we can still make use of a query, which is going to specify the organization Microsoft. And we're going to say to the query, well, it has to start with user hashtag. At that moment, only those items will be returned. And if you only want to specify, or we only want to fetch a specific user from the organization, well, at that moment, we specify the organization and also the user's primary key and sort key. And then we will return that data. Another example that we have is making use of shallow duplications. In this example, we had a class which has some users inside of it. We want to be able to fetch the data from the class and its users, but we also want to make sure that we can fetch the student his details. Well, if we want to fetch the class, at that moment we can specify the class and the semester, and not all the data, but the most important data of the students will be returned. And at that moment, if we want to have more information about the student, well, we can then link towards another API call for querying that student information. Third and last example for design strategy is a many-to-many relationship. For example, we have movie with some actors, and each actor has some roles as well. So let us take a first look on the different entities that we have. We have the movie Cast Away, which is presented by partition key movie and movie. We have an actor, which is presented by partition key and sort key, which also starts with an actor. And then we have a role, which is presented by a partition key, which starts with movie, and a sort key, which starts with an actor. Now over here, if we want to fetch a movie or an actor, it's pretty simple. We're just going to specify it via the partition key, via the primary key, partition key, and sort key, the movie or the actors, and then we can fetch either a complete movie or a complete actor. If we want to fetch a movie and its actors, at that moment we can start by presenting a query, which starts with the movie as a partition key, and we are going to leave the sort key out. And if you want to fetch the actor and its different roles, at that moment we will need to make use of that global secondary index, which I just told you about. The global secondary index at that moment will swap again that partition key and sort key. At that moment, we can still make use of a query, which is going to say, a query, but then on the global secondary index, which is then going to fetch the actor and the different roles where he has played in this example, Cast Away and Toy Story. Now, if you want to learn more about the design of how to model your data for DynamoDB, Alex Debris has written a very good book on this, which is called the DynamoDB book. And I really encourage you to take a look at that, because you will learn very much from this book. At least I have. So if you want to learn more, take a look at that book. Now, if you want to fetch data from C# or from .NET with DynamoDB, there are 3 different SDKs that you can use. You can make use of a standard API model, a data model API, or a particle API model. How does it look? Well, you have, for the standard API, you have to create an Amazon DynamoDB client, and then you can start creating your, in this example, it's a query request. You have to specify the table. Table name in this example is movie and actors, just because we have a single table design and you're storing more than one entity inside of it. And then you have to specify your key conditions over here. You're going to execute the query, client.queryAsync, and then you can start looping over all the different result items that you had. If you want to make use of the data model API, it's a little bit more tankable for people who have already worked with .NET and, for example, an Hibernate or Entity framework. We are still going to make use of that Amazon DynamoDB client, but we will also create the DynamoDB context. We will afterwards query the data based on that DynamoDB context. But we already see over here that we have a class movie and actors model. And over here, we can specify the primary key or the partition key, which is Tom Hanks. Afterwards, we will get the results back and we can load this as well. Now, how does .NET know how to, or which database table that he has to use? Well, in that movie and actors model, we will specify this. We will specify it by making use of an attribute. For example, over here you have the DynamoDB table movie and actors, which is added on top of it. This way he knows on which table he has to search. Then you have some other attributes over here as well. You have the DynamoDB hash key and you have the DynamoDB range key, which are actually the partition key and the sort key, which I was talking about previously as well. I have no idea why they have given another name towards the DynamoDB hash key or DynamoDB range key, but it's just the way it is actually. And then you have the particle API. The particle API is more for people who are making use of queries or who are used to write queries, and then you can do it with a SQL that you see over here. I don't like this very much just because you might think over here that you can forget all the things I've said earlier about making sure that you know your access patterns very well, that you have to know before fetching your data. Well, no, I'm just going to write a query and the data will be returned. Yes, correct, the data will be returned, but it's perfectly possible over here that you will make, sorry for that, if you're making use of select, that you will end up in a scan of multiple seconds instead of a query, which will only be a single millidigit. So be very careful if you're going to make use of this SDK. Now, the next part that I would like to talk about is AWS Cognito, which is about identity management, which is also a very important part if you want to create a serverless architecture. Well, if you're going to make use of AWS Cognito, Cognito will make sure that it's an application or a service which is already responsive and is able to scale, resilient, etc. So you don't have to worry about that anymore. Is the identity management in AWS for creating different applications, which you can use in two forms. You can make use of user pools or you can make use of identity pools. With identity pools, you can gain or create temporary AWS credentials, which you can then use for calling other AWS services, or you can make use of user pools. And this is what we're going to do now, is that user pool is a list of user directories. You can compare it a little bit with the identity server of Duende, for example, where you can add then more and more security features like MFA. You can specify the length of your passwords. You can add it, you can integrate it with Active Directory, Facebook, Google, or whatsoever. And what's nice about it is that it already has a hosted UI which you can use, so you don't have to write your login or sign up screen anymore. And it has very good integration with other applications as well. So let me show you quickly how this works in .NET. I created a very small application, which is just going to show you an API with a Swagger user interface where we're going to call some data after we have authenticated. So the first step that we are going to do is we're going to specify all the different packages that we need, which you can see over here. Then we need to specify the region where we are going to working in and the user pool ID that we have specified in Amazon Cognito. We're going to make use of JWT authentication or bearer authentication. So we'll have to specify as well that AWS Cognito is a valid issuer. and we will have to use then the different services that AWS has provided over there. Next part, because I'm going to use Swagger as my user interface, we will need to add the security requirements over there, adding the Swagger and the Swagger UI. And of course, we will have to add authentication and authorization as well to our API. Now, if we're going to run this, if everything goes fine, and it will be because it's a video which I have already recorded, then a Swagger user interface will be shown. And you can see it's the default weather forecast controllers that we have. And if we're going to try it out, you will see that, well, there will not be a result just because you're forbidden. So it's a 401 which is returned over there. Now, if we're going to authorize, at that moment, you will see that it will work. So here we're already ending up in the user interface that Amazon Cognito is providing for us, where you can sign in or you can sign up with a new user if you want. So here I'm just going to log in. I'm going to provide a password over here. And after I have logged in, I should be able to call the endpoint and get a result out of it. So if I'm going to execute it now, instead of a 401, I get a 200 now, which is returning all the different temperatures that I would like to see. So that's it for AWS Cognito, which is a very easy service to use. And then the next one I would like to discuss is API Gateway, which is actually the bridge between the client and the backend. You can make use of API Gateway to publish and secure your different APIs that you have. It's also a SaaS product of AWS, so it's already responsive. It will scale up, scale down. It's resilient as well. There are three different flavors over there. You have REST APIs, which can be private or public. You have WebSocket APIs, or you have HTTP APIs as well. HTTP APIs are a slimmed down version of REST APIs. And if you want to get most out of it, you can, or you should work with REST APIs. How does such a REST API look like? Well, it's rather easy. You have to specify some resources like your API endpoints for your orders, your get, post, put, delete, etc. You have to specify your models, and then you can start working on it. Of course, you can import it from a given Swagger file as well, so you don't have to craft everything yourself. What's nice about API Gateway as well is that you have three different, or you have multiple stages. I've mentioned now 3, but you can make 4, 5, whatever you want. And it provides you with some caching. If you want to make sure that your application still remains responsive even better or faster, you can add caching towards your API Gateway. And you can make sure that no one is abusing your API by throttling your API Gateway as well. Everything has to work secure, so you can add authorizers as well. For example, the Cognito can be added as well to as an authorizer, so only people who have already logged in can make use of your API Gateway. And what's nice as well is that you can create gateway responses. What are gateway responses? Gateway responses are a manner that you can tweak the response that your backend has given and return the tweaked response to your front-end application. So, for example, if you want to mock some data, it's possible via gateway response. What's also nice is that you have direct integrations. The direct integrations enable you to transport data without having any compute or Lambda or whatsoever involved. For example, if you have an API gateway request and you would like to store it directly on a queue, well, at that moment you don't have to add a Lambda in between to make sure that it's going to be put on a queue. No, you can do it directly from an API gateway, and push the request towards a queue or a DynamoDB, whatever you. And of course, you can tweak the core settings, etc., etc. as well. And I think we are almost ready. What other serverless services do we have? I mentioned in the beginning that monitoring and debugging your applications, if you're going to use AWS Lambda, can be more difficult because you have more and more services running all over your application landscape. Well, with Amazon X-Ray, you can get some nice insights, who is calling who, and how are messages flowing from the one to the other. Yeah, it's a nice service that you have over there. Amazon Event Bridge can be used as a service bus. In between, you have the simple queuing services, which I have already touched a little bit, simple notification services for sending notifications. The S3 is the blob storage service that you have, but you can also use this for hosting, for example, your web application or your single page application, if you would like to do that. And you even have some relational databases which are able to run serverless for their own brand, Amazon Aurora. And if you want to do this, then you should make use of an RDS proxy to make sure that you're not going to create a bottleneck over there. And I think that's mainly it. Here are still some references about DynamoDB book, which I've covered in the beginning, the book of Alex Debris. And then you have some more information over here, some developer guides, which are there. And then I think that's it. Don't know if there are any questions at the moment.
Hi, Rob. Can you hear me okay? Yeah.
Yeah, I can hear you.
Perfect. Yeah, there's one question there. If the data we need is in an existing SQL server hosted on a VM or on cloud, can we still use Lambda and refer the SQL?
Yes, that's perfectly possible. Yes. So you can still use an RDS database or a SQL database if you want to use Lambda. But at that moment, I encourage you to make use of an RDS proxy, for example. RDS is the relational database service of AWS, so the SQL part. And if you're going to use a proxy, he'll make sure that all requests are going to be tunneled to that proxy and you don't are going to overload your database with too many connections. So that's advice I give you over there. But it's perfectly possible to call a relational database. Sure.
Perfect. Yeah. I think that's the only one. I know we're just gone a couple of minutes over. So it's not too bad. I'll just give them another couple of minutes to see if there's any more questions that pop up in the chat. If that's okay, Rob. Thanks.
Yeah, sure.
2 seconds. Rob, it's actually just in relation to there's one question just about another session, but how does Terraform integrate with AWS Serverless?
I think it's just like the other services that you have. If you would like to make use of a Terraform, and well, you have the how it's called in Terraform, the integration that you have, where you can then create the Lambda functions with your Terraform. So yeah, it's not differently compared to creating virtual machines or something else on AWS.
And then just to dovetail off that, then how does the CI/CD pipeline integrate, obviously, with the AWS serverless solution? Or do you need an intermediary between the two of them? Do you?
I don't think there is any difference actually between an AWS serverless solution, because you're going to, at a given moment, you're going to say how your AWS Lambda functions are working, and which services or which Lambda functions you would like to have. You're going to create them via your CI/CD pipeline. It's only a matter if you're going to call them at that moment, they're going to be created or used. But from a CI/CD or from a Terraform standpoint, they will already be there. So it's not that you have to create them with your CI/CD pipeline in a different way.
Because they're already integrated into the system, are they?
Yeah, correct. They're already there. Yes.
That's what I thought. Yeah. Perfect. Yeah. Yeah. It's just gone up on 6 minutes past. Yeah. There's no other questions there, Rob. Rob, I just want to sincerely thank you for your presentation. It was very insightful into I suppose the whole AWS world as a whole. You went into a lot of detail there, and thanks very much. And thanks to everyone else who tuned in here today. And as I said, it's going to be up on YouTube and linked anyway, so you can repeat it again anyways. And again, Rob, thanks very much. Appreciate it.
Thank you very much for having me, actually. So very glad to be here.
No problem. Hopefully we'll do it again sometime. Thank you.
Yeah, glad. Thank you.
Thanks.